Hello everybody. Today we are going to do one of the most fundamental skills that you will need to know to move on to future math classes, as well as being just a large part of what we're going to be doing for the rest of the year in this math class. And that's going to be solving equations. Today we're going to do 1, 2, and multi-step equations. So before we start, one quick clarification. What is the difference between an equation and an expression? Well, first off, an equation has what it almost has in the words, right? It has an equal sign. Equations have equal signs. When we're talking about an equation, we solve that equation, meaning we can find out what our variable is. So for instance, if I solve this equation, I could say x equals blank, some number in the end. Whereas an expression is something that does not have an equal sign. Notice there's no equal sign here. And an expression is not something you can solve, right? If we were to simplify this here, we'd get 5y, 5 times 8 is 40, so minus 40. Notice we don't have y is blank in the end, right? We just have something that we have been able to simplify. So again, equations have equal signs. Expressions do not. We solve equations. We simplify expressions. Today we are going to be dealing with equations. There are a lot of different equations out there that you'll see throughout your math careers, and all of them can be solved using something that we call inverse operations. These are just a few examples of equations that you're going to see throughout your math careers. So let's first talk about what an inverse operation is. So an inverse operation is just an operation that undoes some other operation. So if I asked you what undoes addition, you would say subtraction. What undoes subtraction, you would say addition, right? They're opposites. That's what inverses are. They're just opposites. So if I asked you what's the opposite of multiplication, hopefully you would say division. And if I asked you what's the opposite of division, hopefully you would say multiplication. We are going to use these opposites or these inverse operations in order to solve our equations. So the overriding idea is when we're solving equations is we got to think of this equal sign as like our balancing point. So if you think about a balance or a scale, right? I think I had a picture up here. Right on the first one, if I add something to this side, I need to go ahead and add something to the right hand side so that I keep it balanced, right? What I do to one side, I have to do to the other side. Same idea with solving equations. Whatever I do to one side of the equal sign, I have to do to the other to keep the equation balanced. So what I like to do when I'm solving equations is I like to draw a line down my equal sign, and whatever I do to one side, I have to do to the other. And that line helps me visualize that balancing point, and I'll show you what I mean when we solve some equations. So we're first going to start with some kind of basic one-step equations. So first off, again, where that equal sign is, I'm going to go ahead and draw a line. So I want to get x by itself. I want to solve for what x is. So I notice right now x is with the plus 13, so I have to undo adding 13 to get x by itself. Well, we just talked about the inverse operation to addition is subtraction, so I'm going to go ahead and subtract 13. Again, whatever I do to one side, I have to do to the other. So when I simplify here, the positive 13 minus 13, that cancels out, right? That would just be 0. So I'm just left with x is equal to 14. There's my final answer. You can always go ahead and check your answer by plugging 14 back in for x, and you check, well, is 14 plus 13 27? Yeah, so that means you did it correctly. That's a really nice thing about solving equations is that you always know if you got the correct answer or not by just plugging in your answer. A few more just one-step ones, and these ones are pretty nice because they go fast. Again, whatever I do to one side, I have to do to the other. Right now, to get x by itself, I have minus 8. So to undo the minusing 8, I'm going to go ahead and add 8 to both sides, because what I do to one side, I have to do to the other. Those would cancel, so I'm left with x is equal to 19. Again, just check. You can just check in your head. Is 19 minus 8 11? Yep, that means I did it correctly. This one's a little bit different in terms of what operation we have to use, or what inverse operation we have to use, I should say. Right now we have 2 and x, and since they're touching, that means multiplication. The opposite of multiplication is division. So to get rid of timesing by 2, I have to go ahead and divide by 2. So when I do that, 2 divided by 2, that just becomes 1x, or which is just x, right? We don't have to put that 1 there. And 18 divided by 2 is 9. Again, plug it in just to check in your head. 2 times 9, that's 18. We did it correct. Good. One more kind of simple one-step equation before we get into some more complicated ones. Here I have x divided by 3, so we know the opposite or the inverse operation to division is multiplication. So that means I go ahead and I multiply each side by 3. Dividing by 3 and multiplying by 3, those cancel each other out. It just becomes 1, so we don't have to worry about it, because 3 divided by 3 is 1, and I get x is equal to 15. Again, if I check real quick, 15 divided by 3, that's 5. We did it good. Perfect. Now, what about this one here? We got 2/3 x is equal to 7. So there's a couple ways that you can do this one, and I've seen kids do it multiple ways. Sometimes they think, well, I'm going to go ahead, since it's dividing by 3, I'm going to multiply by 3 first, which is fine, and then they're left with a 2x, and they say, well, then I got to divide by 2. That works. You can do this in 2 steps. However, what I do to get rid of fractions is I go ahead and I multiply by the reciprocal. So what the reciprocal is it's just that fraction flip. So I'll show you why this works. Because if I go ahead and multiply by the reciprocal on both sides, if I look at my left-hand side, I know with fractions with multiplying, I go straight across. So I get 6 over 6x is equal to, I'm going to make 7 a fraction, so I'm going to put it over 1. So I get 21 over 2. Well, what's 6 divided by 6? That's just 1x, or we can just say x, right? We don't need the 1 there, is equal to 21 over 2. Which, if a fraction doesn't simplify nicely, like 21 over 2, I'm okay if you just leave it. If you wanted to put 10.5, that also would work. But I'm fine with just 21 over 2. Again, whenever you have a fraction in there, I just go ahead, multiply it by the reciprocal. That'll clear it out for you. So those are a bunch of kind of one-step problems. Now we're going to get into some two-step problems. In order to solve two-step problems, what we have to do is we have to do PEMDAS backwards. PEMDAS backwards. So in other words, we have to undo the adding or subtracting that's happening first. Then we undo any multiplication or division that's happening second. Another way that I think about it is I just take my thumb and I cover up the x, the term with the x in it. So I cover up the 2x, and I know I have to deal with that last. So when I cover that up, and if I just kind of put a blob over it, pretend that's not there, then I just see the plus 3. So I'm going to go ahead and undo that first. Again, still making that line down the equal sign, because whatever I do to one side, I have to do to the other. So I'm left with a 2x on the left-hand side. Plus 3 minus 3, those cancel, which is great. That's gone. That's what I want. Is equal to 15 minus 3, which is 12. Now it's just like a one-step equation. So I know to undo multiplication, I do division. So I get x is equal to 6. Especially with two-step problems, it's nice to go back and check your answer. So it says 2 times x plus 3 is equal to 15. Well, we just said we think x is 6. So if I check, again, now doing PEMDAS the normal ways because I'm not trying to undo it to get the variable by itself, I get 12 plus 3 is equal to 15. So I get 15 equals 15. So that means I did it correct. X equals 6 is the correct answer. Again, just doing PEMDAS backwards, you have to undo the addition and subtraction first, but just cover up the variable and then you know what to do first. That's what I do. One more here for good measure. Again, I'm just going to use my little highlighter. I like to cover up my variable. I know I'm going to deal with that last. So I'm going to go ahead and draw a line down the equal sign. I see this -1. The opposite of subtraction is addition, so I'm going to add 1 to the other side. So I get 5y is equal to 13. I go ahead, I divide by 5. I get y is equal to, I don't know what 13 divided by 5 is off the top of my head, so I'm just going to leave it as a fraction as 13 over 5, and that's just fine. Oof, what about this problem here? So if we think back to PEMDAS, right, we have to do PEMDAS separate or backwards. When we had problems like this, we knew that we had to simplify the numerator first, then simplify the denominator, and then we did the division last, right, taking the numerator divided by the denominator. So since the division was the last part, that's the part that we're going to go ahead and do first. So I see that I'm dividing by 3, so I'm going to go ahead and multiply by 3 here to both sides. Because if I multiply by 3 and I'm dividing by 3 on the same side, guess what? Those cancel out. So I'm just left with x minus 7. Again, they cancel out because 3 divided by 3 is just 1. So it just kind of goes away. So I get x minus 7 is equal to 12 times 3, which is 36. Then it's just a nice one-step equation. So I get x is equal to 43. Again, you can always check this by plugging it back in, and that's definitely a good idea, especially on any assessments, right? And make sure you got that right answer. All right, so now we're going to do some equations that involve 2 or more steps. So when there's lots of things going on, what I always like to do is I like to try to first simplify each side of the equation first, if possible. That's what I look for. So if I'm looking at this example down here, I notice the left-hand side, I can't simplify, right? It's just 5. We don't have to worry about that. So I'm going to leave that the same. On the right-hand side, remember when we're simplifying, it's either getting rid of parentheses or combining like terms, and hopefully these like terms jump out to you. I got the 5m and the 2m. So 5m plus 2m should give me 7m minus 23. I cannot combine the 5 and the 23 because those are on opposite sides of the equal sign. Think of this as like a wall. You can't just combine things on opposite sides of the wall. You have to move things in order to combine them. So we cannot combine them yet. So my job here now is to solve for m. So I'm going to go ahead and cover up my m. Right, there's my cover up. Pretend that's your finger. I'm doing PEMDAS backwards. So I'm going to go ahead and get rid of this minus 23. So I'm going to add 23 to the other side. So it gives me 28 is equal to 7m. Nice thing is all equations eventually come down to a one-step equation. So to get m by itself, the opposite of multiplying by 7 is dividing by 7. So I get m is equal to, well, 28 divided by 7 is 4. M equals 4. Again, you can check. If we just go back and check, it's always good to do so. So I get 5 is equal to 5 times m, which is we said is 4, minus 23 plus 2 times 4. So if I simplify the right-hand side, multiplication first, before that subtraction, so 5 times 4 is 20, minus 23 plus 8. For addition and subtraction, we do whichever comes first, right? They're on the same level, so I have to subtract first. 20 minus 23 is a negative 3 plus 8. So I get 5 equals 5. I did it correct. That's the beauty of equations. You always know if you have an answer correct or not before you would have it checked by anyone, right? You can check it yourself. I believe this is our last one. Again, thinking back to that idea I just said above here, always simplify each side of the equation first before you start moving stuff around. So obviously there's nothing to simplify on the right-hand side. It's just 36. But on the left-hand side, we can go ahead and use the distributive property. Right, there's parentheses there, so I can distribute that negative 8n. So I first take negative 8 times 2x, so that's going to give me a negative 16x. Then I have negative 8 times a negative 1. Well, negative times a negative is going to give me a positive 8. So now I again just check one more time. Is each side simplified? Looks like it is. There's no parentheses. There's no like terms I can combine. So now I start moving stuff around. Again, I'm not going to deal with what's with my variable first. I'm going to deal with that last in order to do PEMDAS backwards. So I'm going to go ahead and undo the adding 8 by subtracting 8. So that gives me a negative 16x is equal to, looks like 28. So from here, I go ahead and solve for x. So I need to undo multiplying by negative 16. So I go ahead and divide by negative 16. So it looks like x equals 28 over negative 16. Hopefully you're thinking, well, that's not quite done. Well, I don't know, or I know 16 doesn't go into 28 evenly. However, we can go ahead and do some simplifying of this fraction. So what you can think about is what number goes into both 28 and 16. Hopefully you're thinking, well, 4 does. 4 goes into both of those numbers. So you can divide top and bottom by 4 to simplify that fraction. 28 divided by 4 is 7. Negative 16 divided by 4 is a negative 4. So there's my answer. Whenever we can simplify fractions, we should go ahead and do so. So here is our little lesson on solving equations. We're going to do lots and lots of practice with solving equations because it is so important. As always, please make sure you shoot me an email if you have any questions. Just remember those inverse operations. And what you do to one side, you have to do to the other. Thanks.